Welcome back to 5.4. Here we're going to just continue on. There's the one that we just did, figuring out it was in quadrant 3. Now we're going to worry about the tangent of 165 degrees. So here we got to find two angles that we know that add up to be 165. Because again, this must be done exactly. It must be done without the use of a calculator, using square roots and other things like that. So if you think about it, we know that tangent of 120 degrees, well, we know 120 degrees plus 45 degrees is 165, and we know both of those. And so we're set. It's the tangent of 120 degrees plus the tangent of 45 degrees all over 1 minus the tangent of 120 degrees times the tangent of 45 degrees. And again, there's probably other combinations that would have worked just fine. But it has to be two angles that we know everything about, right? That we don't have to turn to a calculator for. Otherwise, we won't have the exact answer. So 120 degrees has a 60-degree reference angle in the second quadrant. So my tangent's going to be negative. And 60 degrees, as you remember, is root 3. Tangent of 45, that's the first quadrant. And 45 has a tangent of 1 all over 1 minus. Tangent of 120, we just already figured out, is negative root 3. And we figured out the tangent of 45 is 1. And so this happens a lot, where we have the negative root 3 plus 1, and on the bottom, 1 plus root 3. Okay. And so how are we going to deal with this? We're going to multiply by 1 minus root 3, because the only reason we're not done is we have an irrational denominator. And so what do we get up top? We get negative root 3 plus 3 plus 1 minus root 3, and that's all over 1 minus 3. So what's that equal to? Let me get rid of a mark here. What's that equal to? Well, let's put some things together. It looks like we have a 4 minus 2 root 3 all over negative 2. And so they're going to say the final answer is negative 2 plus root 3. Right? They're going to take both of those and divide by negative 2 independently and get a really nice answer out of that. Again, if you were to plug tangent of 165 degrees into your calculator, you'll get the decimal representation of this perfect exact number, negative 2 plus root 3. That's what we need. Here we go, sine of negative 13 pi over 12. Well, let's talk about getting negative 13 pi over 12. Maybe we'd have to go farther out, like 5 pi over 6, because that's going to give me 10 pi over 12. That gets me close. Can I get a 3 pi over 12? Sure. A 3 pi over 12. Think about who's 3 pi over 12. That's pi over 4. So plus pi over 4 will do that. Now, I want negative, so let me make both of these negative. And it works out perfect. So let me erase the justification and go back to the angles that we know. So it's just a game, and you want to play the game. It's a good thinking type of game. So this is sine of negative well, let me do sine of negative pi over 4. Let me reverse these, just because I think it will be better for me. So sine of negative 5 pi over 4 times cosine of positive 5 pi over 6. Because it was sine, cosine, and they're different, it's going to be the exact same sign. So it's going to be a minus sign in the middle, right? Remember, we're doing this. And then we're going to have the cosine of the negative pi over 4, and then times sine of 5 pi over 6. And as we do that, the sine of negative pi over 4 is also going to be negative. This is negative root 2 over 2. Cosine of 5 pi over 6, that's a second quadrant angle. So it's negative. It's a pi over 6 angle, so it's root 3 over 2. Minus cosine of negative pi over 4, that's positive, because that's a fourth quadrant angle. Sine of 5 pi over 6 is also positive, because it's a second quadrant angle. And so we have a positive root 6 all over 4 minus a root 2 all over 4. and they'll have the end answer of root 6 minus root 2 all over 4. That nice, right? And you're going to be able to, on those ones that are recommended, you'll be able to flip to the back of the book and see that you have the right answer. If you want to know whether your answer is correct for an even one, one of the ones you're doing for the required, you certainly could take the sine of the angle, write that down, right, the way that you see it, and then figure out what root 6 minus root 2 divided by 4 is, and those numbers should match exactly. So again, they're going to help us out by having us do identities. You should not go with the thought that because we're getting longer, the identities are getting harder. Identities typically don't build up in level of difficulty. It's just circumstantial which ones are difficult or not. You're going to find that this one is super easy, because what's sine of x plus y? It's sine x cosine y plus, right, because it's a plus, it's the same in the middle, cosine x sine y. What's sine of x minus y? Easy. Sine x cosine y minus cosine x sine y. Now take a look at those. Who can go away? Well, I got a cosine x sine y minus cosine x sine y. They're gone. I have sine x cosine y twice. I got 2 sine x cosine y's. Done. So in one line, just by knowing the sum formula for sine, you are finished with that. How about this one? Sine of s plus t all over cosine s cosine t. So take a look at what you have and what you need. What you need is just a straight old tangent function in there. No quotient. So let's see what happens. Sine s plus t. Easy. Sine of the first, cosine of the second. Those were different functions, so we're going to use the same sign in the middle. Cosine s, sine t. And that's all over cosine s, cosine t. Now, one of the most used tricks in the book is when you have a solid denominator. Now, your denominator is a product of two things, but that's solid. It's not split over a sum. Then we split this up. Sine s, cosine t, all over cosine s, cosine t, plus cosine s, sine t, all over cosine s, cosine t. So all that happened there is I took my solid denominator and put it under each one. Let's simplify. What goes away with the very first one? The cosine t's go away. What goes away with the second one? The cosine s's go away. Look what you're left with. You're left with sine s over cosine s plus sine t over cosine t. Sine of an angle divided by cosine of the same angle is tangent of that angle. And you are finished. You have the right hand side all done. That is what's happening in there. Is just good familiarity with this and good mathematics going on. So that's the 5.4 section.